construction manager. It's known as the Silverdome because of the way its fiberglass roof gleams in the sunlight. The magazine Engineering News Record called it one of the great design and construction achievements of our time. The National Society of Professional Engineers voted it one of the 10 outstanding engineering feats in the U.S. in 1975, ranking it along with the Apollo-Soyuz joint U.S.-Soviet space mission. The Associated General Contractors of America, in cooperation with Motorola Communications, presented Barton Malow President Roland Wilkening with the coveted Build America Award. Guest of honor Bart Starr, Green Bay Packer great, extended congratulations. And there were more honors, more plaudits, from such organizations as the Engineering Society of Detroit and the Concrete Improvement Board, and from prestigious publications nationally and internationally, as well as from prominent Michigan writers. Why this widespread interest? Well, all over the country, people had grown used to hearing stories about problems, delays, runaway inflation in stadium construction. For example, the New Orleans Superdome, which was initially supposed to cost $35 million, but wound up costing $168 million. For the Pontiac Silverdome, which has 10,000 more seats, the cost was $55.7 million. This figures out to $691 per seat. Construction time was just a day over 22 months. In New Orleans, the per seat cost was $2,333. Construction time, 48 months. And here are comparative figures for other stadiums. The Kingdome in Seattle, cost per seat, $923. Construction time, 44 months. The remodeling and modernization of Yankee Stadium in New York. Per seat cost, $1,692. Construction time, 30 months. And the Olympic Stadium in Montreal, $7,902 per seat. Construction time, 51 months. The contrast was so great that the magazine Sports Illustrated commented, "Close observers of stadium construction will be shocked by what is happening outside Detroit. Pontiac Stadium, roof and all, is being brought in on time and almost exactly on cost."
Comments like these were very gratifying to us at Barton Malow Company. It has been a truly challenging project. One of the principal reasons we were able to remain on target was the fact that the stadium was built through the method known as construction management, rather than through conventional contracting methods.
Under this method, the owner, the architect, and construction manager operate as a team. The construction manager is primarily responsible for cost estimates and cost control, review of design with a view towards value engineering, consultation on construction techniques, coordination of construction and scheduling, and direction of all construction activities.
Ground was broken September 19, 1973 by the mayor of Pontiac, the owner of the Detroit Lions, and the Pontiac Stadium Building Authority chairman.
By this time, Barton Malow, as construction manager, had held many meetings with members of the authority, the architect, Odell, Hewlett, and Lukenbach. All material, labor, and equipment requirements were thoroughly analyzed. We reviewed the availability of materials and considered possible alternatives to complete the project at minimum cost in the least amount of time.
The site of 132 acres included several swamps, which had to be drained, compacted, and filled. The grading and clearing required the services of the operating engineers, and they were idled by a labor dispute. It was mid-October when a settlement was reached and the work got underway. Mike Makuta, architect's representative, and Barton Malow Vice President Bill Dryberg, who served as the project manager, recall the problems.
right here behind us a typical type of terrain that we started in the first stages where we had to cut and fill.
Yeah, well, it was like this.
Just like this.
And worse in some areas.
We had 4 swamps to contend with, which we drained and surcharged and allowed to settle for a period of some 12 months.
Land balancing involved 1,350,000 cubic yards. Despite the late start, 2/3 of the site preparation was complete by the end of the year. The original design had called for spread footings to support all columns. In view of the delay and the onset of winter, this would have thrown the project behind schedule.
Here is an instance of the flexibility made possible by the use of the construction management method. A very detailed study was made with the structural engineers. As a result, we switched from spread footings to caissons. We placed 236 of them, from 4 feet to 7.5 feet in diameter, at depths to 80 feet. Shell liners prevented the sides from collapsing in the augured holes. The caissons enabled us to avoid open-cut excavation, forming and backfilling, allowing construction with less concern for winter conditions. Meanwhile, another serious problem had arisen. Here again, the construction management method facilitated a solution. The original stadium structure had been designed in structural steel. During the late summer of 1973, steel costs began to soar. This could have meant at least a $250,000 price increase. A study was quickly launched to see whether or not we could avoid this additional cost by totally redesigning the structure in concrete. It was found by so doing that we could save the $250,000 and also improve the construction schedule.
The design changes were made during the winter of 1973 and the early spring of 1974 without interrupting the building schedule. It was another dramatic demonstration of the advantages of the construction management method. By late December of 1973, the pouring of wall footings, walls, and columns was underway. Care was taken to protect them against cold weather. In addition to serving as construction manager, the Barton Malow Company, as general contractor, was awarded the contract for all the concrete work through competitive bidding. As soon as the preliminary work was sufficiently advanced, they proceeded with the lower girders. By June of 1974, they had progressed to the upper girders. All of the girders were poured in place by means of a special self-supporting forming system developed under the direction of Barton Malow Senior Vice President Floyd Wieland, who is seen here discussing the system with Ben Maybach III, Executive Vice President. Here is a lower girder form being set into place. Cages of steel reinforcing were assembled, then dropped into the forms. The component form and reinforcing steel weighed 55,000 pounds. Each form was used for 16 pours. There were 3 of the lower type and 4 of the upper. Here we see a lower girder form being removed. Much of the concrete placement was done by pumps, supplied by the Cloverdale Rental Company, a firm closely related to Barton Malow. The use of concrete pumps is rising rapidly. Recent technology has made them capable of operating at almost any height and under most weather conditions. Here, a pump hose is being placed. Of course, not all the concrete was placed by pump. This is an example of concrete placement using the conventional bucket method. The playing field was to be excavated 40 feet below the field level concourse and 50 feet below the parking lot. It was held at 15 feet below the concourse, however, while the concrete work was in progress. This allowed a working platform for the 200-ton crane needed for the handling of the girder forms, and it also provided a logistic storage area for forms and reinforcing steel. With the pouring of more girders, the stadium gradually took shape. 1 year to the day after groundbreaking, it looked like this, representing 11 months of actual construction. As sections of the concrete framing system were completed, installation of precast units was begun. These included 10-foot wide twin T's, 28 feet long. The majority of the stadia sections, each comprising 3 tread and riser units, were erected during the fall and winter months.
Here we encountered another major problem. Right in the middle of the project, the firm manufacturing the precast units ran into financial troubles. This was in the fall of 1974. The firm was put under federal court control. We then arranged to operate the plant for the court-appointed receiver and were able to produce the needed units.
The project was progressing on schedule, but there were occasional setbacks. For example, on December 2nd, 1974, we had a 21-inch snowfall.
Not a great deal was accomplished in the next day or two. They were doing pretty well justifying the stadium. It took another week to dig things out and get back into full operation. The snow was still there when the first seats were installed. 20 were put in to see how they looked and to develop the most efficient method of installation. With a major portion of the structural concrete and precast work completed, the next step was to excavate the bowl down to the playing field. The excavated earth, some 250,000 cubic yards of it, was used to build berms adjacent to the stadium and to provide inclined ramps up to the club and upper-level seating areas. This is the world's largest dome stadium. In late February of 1975, erection of structural steel got underway for the tension ring, which supports the unique fiberglass fabric roof. The steel was all in place by May 15th, a total of some 1,800 tons. The floating ring, half cantilevered over the outer row of columns, has no expansion or contraction joints. All of the interior columns rest on Teflon wafers to allow movement up to 6 inches in a horizontal plane. There are 6-foot deep web members on each side of the ring, which has an 11-inch concrete slab cast on a fiber plank permanent form system, with an 18-inch concrete wall on each side. The ring is 23 feet wide and encircles the structure for a length of 2,300 feet. It is 32 feet above the upper row of seats and 105 feet above the parking lot.
Meanwhile, from March through June of 1975, we proceeded with the lower seating sections of the stadium. These sections were poured on grade, and for this purpose we developed a special form system which not only set the grade and the elevation, but also provided the form for each riser for the lower seating section. Insulated metal siding was used for the exterior closure to ensure maintenance of air pressure to support the roof. This had to be completed by September 25th in order to meet our October 2nd date for inflation. The roof is supported on steel cables. It would have taken 3 weeks to string them in the conventional manner. We needed a faster way. Ben Maybach III and architect Carl Lukenbach joined me at the site as we brought in the largest helicopter available, an S-64 Sikorsky with an FAA rating of 20,000 pounds of lifting capacity. The cables are of galvanized steel, 3 inches in diameter. They range from 550 to 750 feet in length and weigh up to 16,000 pounds each. The big helicopter picked them up from the parking lot, carried them over to the stadium, and lowered them into place. High winds hampered the operation at first. We immediately closed it down because safety is always our #1 consideration. We brought into service a second power winch so that both cable ends were under constant restraint. The cables are secured by open strand sockets at each end to the tiebacks on the compression ring. Each clevis weighs 300 pounds. The pins each weigh 96 pounds.
The total length of the cables is about 2 1/3 miles, and they weigh 125 tons. The whole mix of cables and fabric weighs 200 tons. A conventional roofing system of equal size would weigh 30 times as much, or about 6,000 tons. The entire job of placing the cables was completed in one weekend, a total of 11 hours flying time on June 14th and 15th, 1975. The installation of the roof fabric was carried on from July 1 through October 1, 1975, as the contractor strove to meet an inflation date of October 2nd, 9 months ahead of contract schedule. The fabric is 1/32 inch thick Teflon-coated fiberglass. Initially tan in color, it gradually bleaches to a gleaming translucent white. Its area is about 400,000 square feet, nearly 10 acres. The 100 panels were installed in the air, working from suspended work platforms, using a crane and 4 A-frame towers to pick up and roll out the fabric panels. The roof weighs slightly less than 1 pound per square foot and is air supported at 3 to 5 pounds per square foot. In maximum snow load conditions, it may take 12 pounds per square foot to support it. The surface of the roof panels is extremely smooth due to the Teflon coating. This gives the material a self-cleaning action with every rain. Under tension, the fiberglass yarn is pound for pound stronger than steel and less expensive. It also resists burning, shrinking, rotting, or mildewing. Estimates of how long the roof will last range from 25 to 50 years. This system has been used to cover other structures, notably the U.S. Pavilion at the 1970 World's Fair in Osaka, Japan, but never on so large a scale as the Silverdome. Wide use of the system is expected in the future for many types of structures. The supporting pressure is applied by 25 blowers, each powered with a 75 horsepower motor mounted on the roof ring. These also were lifted into place by helicopter. Heat is provided by 10 of the blowers and 4 indirect gas-fired units. The number in use at any one time depends on the outside temperature, wind and snow conditions, and the kind of event scheduled. When the stadium is not in use, 4 or 5 of the blowers are enough to keep the roof inflated. While the roof work was proceeding, so was the installation of the seats. The schedule called for $10,000 a month, but the installers managed to reach a rate of $16,000 a month. The 80,600 theater-type seats provide much more space per spectator than the old-style benches. If bench seating had been used, as at the University of Michigan Stadium and the Rose Bowl, the Silverdome would seat in excess of 120,000. Installation of the seats required the drilling of holes for about 175,000 anchor bolts.
With the first preseason football game scheduled for August 23rd, it was now time to install the AstroTurf to cover the playing field. A special machine was used to handle and lay each roll. There are a total of 28 rolls, each 15 feet wide by 234 feet long and weighing 3,600 pounds. A continuous nylon zipper joins the rolls together to form a total covering. Because of the early completion of the stadium, the Lions were able to schedule a preseason game as early as August 23rd. Heavy rains delayed the building cleanup and asphalt paving of the parking lot. With the roof only partially installed, the playing field got so wet it could not be striped. We brought in a couple of helicopters to fan it dry. The stadium was ready for its first football crowd.
Fans streamed through the gates, gasped in admiration of the stadium, enjoyed the pregame entertainment, and cheered the Lions. To make it a perfect afternoon, the Lions won the ball game. On October 2nd, the stadium got its finishing touch. The big roof was inflated. It was a gala occasion as hundreds of guests, including VIPs from all over the world, gathered to watch the climactic event. There had been more heavy rains. The roof fabric held a number of large pockets of water. The crowd watched in suspense. Would the blowers be able to generate enough pressure to lift the dome? The suspense didn't last very long. Excess water was pumped out and the big top inched upward. As it made its final surge, the crowd burst into a rousing cheer. The stadium, including its private boxes, spacious press facilities, and 112 acres of paved parking, was now ready, not only for football, but for an infinite future of stirring athletic, entertainment, and cultural events, such as the record-breaking Revival Crusade conducted by evangelist Billy Graham, which had a total attendance of 365,000 people, including 70,000 at a single service. And record crowds also for popular entertainers such as Elvis Presley. The Silverdome also provides an unmatched facility for community events, such as a gigantic Scout-tacular, at which boys and girls demonstrated the skills and learning they've acquired through scouting. For the citizens of Pontiac and the rest of the metropolitan area, the completion of the Silverdome was an occasion of great civic pride.
For us at Barton Malow, also, it was a memorable moment. Building the stadium has been more than a job to us. It has been an adventure we will never forget.
Our original contract called for 800 days from start of construction to beneficial occupancy. The first game was played 670 days after construction began, 130 days ahead of contract schedule. The original contract for the roof installation called for the roof to be completed by June 30th, 1976. It was in place and inflated 9 months earlier than that, October 2nd, 1975.
The overall compression of the construction schedule reflected substantial dollar savings for the project, since all of the work was able to be performed within the framework of existing labor contracts. A total of 2,536 union construction tradesmen, representing 17 different trades under the leadership of the Greater Detroit Building Trades Council, completed the entire project without any work interruptions.
Cooperation of the owner and the architect engineers had been exceptional. We feel it has been the best test yet of the construction management method.
In my 20 years of experience as an architect, I have to say that this has been the most gratifying and probably one of the best team efforts ever achieving a structure of this kind and of this magnitude.
During the construction period, the industry as a whole had experienced some of the greatest inflationary increases in material prices of the last decade. Yet the construction management team had been able to cope with the inflationary spiral by the accomplishment of alternative design and the substitution of materials without sacrificing quality, further also maintaining cost control within the original budget. Finally, and most satisfying of all, was the simple fact that in the face of many difficulties, we had been able to attain the goal that we hold before us in every project, to finish it on time, within budget.